process industry. So I'll just flick over. So I'm Mike Hells. I'm the process marketing manager for Europe, Middle East and Africa. So predominantly I support the ASCO product range, but my previous positions were as TopWorks product specialist. So I have a good background on these topics and be able to give you an overview of what we can offer. So just as a product overview, again, you may have seen this slide in the past, but the definitions of context, it's a big word that's used very often these days of Industry 4.0, but what we're basically saying is that through the Industrial Revolution, we're at a stage now where we're looking at the Industry 4.0 being a data or digitalization of processes and systems. And how that works with ourselves is obviously the IIoT, which is the Industrial Internet of Things. And another phrase that we like to use within Emerson is floor to cloud. And what that basically means is that we're able to analyze some of our processes and some of our technology that we use in machine automation or process automation. And from that, we're able to use diagnostics and statistical data, which can then be transferred into what's known as the cloud, which is basically means that it's in the sort of internet space. And then we're able to access that information anywhere across the world, be able to act upon any of the diagnostic data that we receive or any of the information. So in a DX process, what we have is we have to have some DX ready process products. And within the process industry, what we have is we have a number of products which allow us to give digital feedback. So digital feedback is a sort of 0 to 1 or on-off system of being able to give an electrical signal back. And then from that information, we can interpret that as how long it takes to energize or how long it takes to feed back, how many times it's feeded back. And then we can use that information then to diagnose how healthy our system is. So that's the simplest form of digital feedback or DX that we have. And then what we have is some advanced diagnostics. So with some of our TopWorks product range, we have the ability to have a heart signal, which again gives us a lot more advanced diagnostics. And then we look at the systems like the AF2, which is again able to analyze data in a greater format. And then we're using some of our RIX products to then interpret that data and be able to give us things like a graphical display, or using some of our software such as Movicom to be able to give that to a customer in a format that you can easily interpret. So look at some of the challenging solutions. So again, this big word, the connected from device control from edge to cloud. So some of the areas where we've seen some benefits is that in energy consumption, around 20 to 30% is lost in compressed air. Downtime, so when obviously you're not able to monitor a process, if you're not able to analyze the data, then we're looking at being able to reduce a downtime in unplanned maintenance. And again, by using that statistical data, we can actually increase operational equipment efficiency to around 5 and 10%. So looking at some of the systems that we use, with preventing unplanned downtime, we can monitor a life cycle of key devices. So again, within the process industry, we have things like actuated devices, actuated valves, and with actuated valves, we do not know whether the parts need to fail, or we don't know if we need to replace them until they fail. So a lot of these systems are in place and we don't actually know how many times they're being operated, how many times they're being in service. But by using this statistical data, we're able to manage the life cycle of products, and in something like an actuator, it's measured in sort of mileage. Or in valves, it's measured in cycles. And then what we're able to do then is use that data to be able to predict when is the correct time to manage or to have a shutdown to be able to replace these parts. So less unplanned downtime can improve the throughput and improve the efficiency of our system. So reduced energy consumption and spend. Again, I was looking today at the cost within our own factory, and the carbon footprint, which again is a very important, net zero is a very important system that people are looking to work towards. But one of the issues that I do have is how to manage that, or how to represent that they're reducing the carbon footprint. So again, one of the costly energy consumption usages within compressed air. So typically, a manufacturing plant can lose around 30% of compressed air due to leaks. And we're reducing wasted energy and the compressor air costs, and that can be very costly for our customers. So over time, air leakage can lead to increased energy costs and machine downtime. But if we're able to analyse the airflow, and we're able to analyse where these leaks are and manage them in an efficient manner, then we can reduce energy consumption and spend. Another important factor within the process industry is improvement of availability and safety of the process. And one of the systems that we have in place is an advanced redundant control system. And what we're able to do is we're able to increase the safety without impacting the availability of plant. So we're using voting systems, and again, we'll talk a little bit around the voting systems later on. But we're looking at a 1 out of 2 system, or a 2 out of 3 configuration, which improves our safety integrity levels. No nuisance trips is especially a problem on a large plant. If you have a number of systems which are monitoring and they receive bad information which can shut down your plant, that could result in an unwanted closure of a process valve. And again, we've seen some benefits in being able to offer a customer a solution within a redundant control system. So what we're going to look at now is the products that we have available. So first of all, we're going to look at the TopWorks solutions. So typically TopWorks is a discrete valve controller or a switch box, and we also have the Go switch, which are 2 unique products within our portfolio. So with a switch box, what we have is we have advanced feedback options. So on the top left there, we have a heart module inside a switch box, which is able, again, to give us advanced diagnostics. And aside from heart, we also have different protocols. So one of the popular protocols in advanced feedback is foundation field bus. And again, within the foundation field bus, we have a solution within the switch box range. And on the right-hand side, we have another system that we have, which is a partial stroke test. So the partial stroke test on the top has been around for around 15 years, which is just a standard process. And what we're doing there is that a lot of products are constantly on or constantly open. But when you need that product to react in the event of a catastrophic failure, you want to ensure the integrity of your product or the integrity of the valve. So one of the systems that we use is a partial stroke test. And what that does is enables you to open the valve or close the valve within 5 to 10 degrees of the actual fully closing. So you're not interrupting the service of the valve, whether it be always open or always closed. But what you're able to do is to maintain that the product is working efficiently and correctly. And that will give you some diagnostics back to confirm that the product has moved. And then in the next stage, what we have is a more advanced partial stroke test, which again incorporates the heart device. And the heart device has, again, a number of diagnostic feedback options which are related to the device and also able to receive inputs from separate devices. So, for example, on a pipeline, you may have a pressure monitor on that pipeline. And what you can do from the pressure monitor is you can feed that device into the heart signal and be able to read that heart signal and again, give you advanced diagnostics to give you if you like, a complete feedback on that device, so a complete closed feedback loop. So on the Heart 7 device, this is typically some of the diagnostic features that we're able to measure. So analog position, so that means is instead of an open or closed position, we can actually measure how a valve is moving. So we can measure from 0 to typically 90 degrees, which is what a valve valve devices to open and close, so we can measure that path all the way. And what that gives you is the ability to see how long that takes, and you can measure each of those positions to see whether it's juddering, whether it's taking longer to open or longer to close. We can obviously test the fully open and fully closed signals. We're also able to test the internal temperature. So if you get an over temperature inside the device, is that because we have some issues that we need to be aware of and we need to investigate? And what we're also able to do as well is measure the timing in milliseconds. So if a device is taking a lot longer to open or a lot longer to close, then again, that gives us some advanced diagnostic feedback that we can be able to react on and do some investigation work or make some, some results on that. So if it's opening or taking too long, we can do some maintenance on that device to make sure it's operating correctly. So because obviously TopWorks is an Emerson device, we talk directly to the Delta V system. So what that means is that we don't need to have any additional hardware. If the client has a Delta V system in place, it automatically recognizes the TopWorks device as a generic device that Delta V can read. And the displays that the customer sees are exactly the same with any other Emerson device, whether it be a Rosemount transmitter or a Rosemount temperature gauge or a pressure gauge, etc. We're able to see the same diagnostic features and set it up. So if the customer already has a Delta V in place, he'll be very familiar with the way to set up the device and be able to manage the alarms and other systems that you're able to set. As well as a Delta V device, it also works with the AMS Trex, which is the handheld device. And again, what we've seen some benefits in people not being able to fully integrate a heart system, but being able to use some of the diagnostic features or read some of the diagnostic features with the Trex and make, again, decisions on that device to see whether it needs any maintenance or whether it's operating correctly. So again, heart is not something that's particular to Emerson. There's millions, tens of millions of heart devices globally. So what that means is that our device will talk to any heart-enabled system. So it doesn't have to be a Delta V system. It can be a Honeywell system or another system. So we're able, again, to read that information, and they're also able to read the diagnostic features. And obviously, analytics can be created for every different environment. You may need different parameters. So a food and beverage application may be open and closed all the while. So you may be able to monitor that. You can configure the alarms to suit whatever application. So an oil and gas application or a food and bev or a water wastewater, they may need different parameters to determine whether the preventative maintenance is needed. And again, with this device, you're able to monitor and you're also able to configure different alarms to suit the actual application. So again, what we have here is just a sort of very, I suppose, holistic view of the devices that we have in place. So typically what we have down here is we have a simple on and off valve, and that has a simple device which is measuring the open or close function on an emergency shutdown. And again, this is a standard product. So this particular one is one of our competitors, but they, again, all look very similar, sit in the same device. But what we're able to do is if we have a heart-enabled device, that will still read the open and close signal. And it may be that a customer wants to future-proof his plant, enable for us to, at the time he's not heart-enabled, but in 5 or 6 years' time, he may have the infrastructure in place to be able to read that. But by installing a heart-enabled switch box into a standard switch box, then you're DXing or future-proofing your plant. What the customer is able to do then with an AMS Trex is he is able to use some of the diagnostic features that are available with the heart device, and then be able to make educated decisions on whether that device needs to be maintained, it needs to be put out of service, and read some of the analytic features that you will get back from that heart device. And typically, if we look at some of the largest refineries in the world, and we equate that to how many barrels per day it makes, the cost of installing some of these products is absolutely minimal. The return on investment is basically seconds. So, you know, if they have to shut down the plant or they have to replace the products, and then the return on investment by being able to analyze the data and have, you know, educated advancements on when you do need to shut the plant down, the returns on investments are very quick. So as I mentioned, on the D series, we have foundation field bus, and that has, again, a number of features that you can set. So it's integrated within our AMS or Delta V systems, but again, foundation field bus is not unique to Emerson. You can connect that to any foundation field bus configurable system, DCS, and be able to read the advanced diagnostics. As I mentioned previously, what we have the partial stroke test. So again, the typical function of an emergency shutdown valve is they're normally static for long periods of time, either in an open or closed position. Essentially, what a customer needs to be aware of, and again, it's in legislation in some areas of the world, is they need to be able to ensure that if on demand that device is actuated, that it will respond. So again, if it's an ESD, which is an emergency shutdown valve, that's an integral part of a safety system. But at the same time, what a customer doesn't want to do is he doesn't want to shut down his complete process. So what we will need to do then is he will need to be able to make sure the valve's functioning correctly and operating, but at the same time not shut down the complete plant. So there we have the ability to offer a partial stroke test. So that just opens or closes the valve to around 20 degrees. And again, make sure the integrity of the valve is correct. And we have some standards that we, you know, periodic proof tests that are needed to ensure the safety function of the valve. And that may be part of a site's legislation in terms of, you know, to ensure the insurance of that site is maintained. They'll need to periodically proof test all the products. And this is a way of doing it without shutting down the plant. So a recent device that we've added to the range is the DX PST. So again, this is a partial stroke test. But what we have is we have more diagnostic features. So typically, as well as the partial stroke test, we're able to do a valve signature. So what a valve signature is, that we can test the valve when we first install it. We're able to take that signature and then monitor that signature over time. And if there's any deviation in that signature, then we're able to perform maintenance on the product and maintain the product in a working order. So we're able to do that remotely with the AMS Trex in the control room, or on the device. We're able to do some of these functions. As you can see on the side there, we have a padlockable push button. So during maybe shutdowns, the device can be tested and make sure that the partial stroke is functioning correctly. And as well as the partial stroke, what we're able to do as well is add additional features onto the line. So as I mentioned before, some of the typical features that a customer may have is pressure monitoring. So we may need to make sure that the pressure in his plant is performing efficiently. And again, what we're able to do with our Heart 7 device, it has additional channels. So you're able to feed back in that pressure transducer into the heart signal and be able to go back to the control room and analyze that data. So again, this could be very useful for a customer who wants to have a complete closed loop to enable him to check that the whole system is working efficiently. So again, we're able to do similar analytics by the handheld device, the AMS communicator. And again, we're able to set the parameters in terms of alarms, etc., and be able to take some diagnostics directly at the device. So there's just an overview of the two different devices. So as mentioned, we have the standard PST, which we've had for around 15 years without the advanced diagnostics, but that still has some diagnostic features to enable you to the customer to see that the partial stroke test has been performed correctly. And we're able to, again, on the side with that padlockable panel, be able to test the partial stroke either remotely from the control room or on the device during maintenance, when the maintenance guys need to go around and just make sure that's functioning correctly. So another part of the portfolio, as mentioned, is the Go Switch. And on a number of our products, we've incorporated the Go Switch because of the features and benefits of this product. The design is very unique. The Go Switch is able to withstand a lot of harsh environments. So it typically works from -60 to 204 degrees Celsius. And it's also able to work under extreme pressures. So obviously we generally have pneumatic pressures, but the Go Switch will work in hydraulic pressures and subsea pressures. So, you know, it's able to withstand tens of thousands of PSI, and not just the standard, you know, 140, 150 PSI that we may see in our systems. So you can see we've got a number of devices there where we've actually had some feedback on an X344 valve and an 215 valve. And again, we're able to use that as a feature of a safety feature. And because the Go Switch doesn't maintain any power or doesn't need any power to operate, typically a lot of the sensors that we use within our portfolio, something like a hall switch sensor or a proximity sensor, they actually need a 24-volt DC supply enabled to give you any feedback whatsoever. So what that means, in the event of you know, a particular system having a failure, it doesn't need any voltage to give you a signal back. And what that's able to do is we're able to connect that to wireless systems. So Rosemount offer a 702 transmitter. And what we're able to do is we're able to use that 702 transmitter to receive our signal, our digital signal from the Go Switch. And because it doesn't maintain any power or doesn't need any power to operate, that means that a typical system could be in place for up to 5 years and still have feedback and still be able to monitor. So for things like safety systems, it's very important. But one of the applications that we do have is a safety shower. And again, we're able to maintain that signal if in the event of somebody operating the safety shower and needing some assistance, we're able to send that signal across. Excuse me. So again, we also use the Go Switch on our redundant control systems, and that's an internal of how the device works. So internally on there, we have the connections. Typically, a 327 device only has to move around 1 millimeter, and we're able to sense that 1 millimeter movement and be able to give some feedback. So again, in a lot of systems, what we're able to do is connect that up and make sure that the device is actually moved and give some additional feedback to systems, which typically on a Go Switch or a normal system you'll be able to analyze. But in some of the other systems, we're actually able to conform to standards. So on the combustion standards, they actually need a physical feedback or proof of closure switch, proof of closure mechanism. And by incorporating the Go Switch, we're able to achieve you know, those standards and be able to offer a solution to our customers. Another device that we have within our portfolio is the Smart Digital Positioner. So positioners within the Emerson range, we have the advanced positioners like the 6200, the DVC 6200, and now also the DVC 7000, which is the latest device. Where we sit is perhaps at the different tiers of that advanced diagnostics. We don't offer as many diagnostics as a DVC 7000 or 6000, but typically in a lot of our applications, customers only after a certain amount of diagnostic feedback. And again, we're able to offer positioners that give that solution to the customer at a more competitive price in comparison to larger diagnostics. So what is a valve positioner and why do we use one? So typically they're used on a control valve. So a control valve is essentially a flow control valve. And what you need to do is you need to be able to position that between not only open and close, but 10%, 15%, 25%, 50% of open. And that percentage will give you a certain flow outside of the valve. So the valve that you see on the right-hand side there is a typical control valve. So these are used heavily on control valve functions. But what we see more in the industry is that even on quarter-turn valves, the on-off valves typically that we have within the process industry, customers again are wanting to have advanced diagnostics and be able to get more feedback. And we've seen more and more that instead of having an on-off feedback device like a switch box, customers are moving more towards a valve positioner to give them more diagnostic features and again be able to get some more communication back to the device. So looking at the PD series, some of the features and benefits of that product, PD 100 being the 4 to 20 milliamp feedback only, but the PD 200 to have the heart communications protocol and a little bit more configurable features. So looking at the ASCO solutions now, and as we all know, ASCO are certified safety and reliability. When people think of a device that's very high quality, that's at the top of the portfolio, then ASCO is always used. And a lot of times we're part of the reference list. So what we'll see, especially in the process industry, is ASCO or equivalent. So we have a number of solutions from your standard solenoid valves, moving across to modular systems, and then moving over to the more advanced customization systems. And as we all know, that's where we do have added value. So one of the systems that we'll be looking at today in the modular system is the ARCS. So ARCS, again, is typically used on emergency shutdowns. So an emergency shutdown valve or an ESD valve, some of the issues it can potentially have with that product is a single process valve can be jammed, it can have a valve stem that's broken. Looking at an actuator, again, that can have issues in terms of jammed, broken springs. And with our device, a solenoid valve, we have similar issues to deal with. So that's seen as a safety and reliability issue. And again, with the solenoid valve, some of the issues that you have is unnuisance trips, so unscheduled stoppages. That could be a pneumatic failure, electrical failure. A typical one for a solenoid valve is a burnt out coil. And what we're trying to do is we're trying to reduce these situations, because each time you have one of these situations, it can produce a lot of downtime. And as we mentioned with a few slides back, when we're looking at a large refinery like Jamnagar, the potential losses run into millions if that's down for any period of time. So what's a redundant system? So a redundant system is not a single valve, because what a single valve does is, we have the inherent safety of a single valve, but what we're looking for is we're looking for redundancy in the fact that if something happens with that valve, that one valve, we have additional valves for us to either create a more safety or a more reliability functionality of the end device. So typically we have a 1 out of 2 system. So that's looking at increased reliability or safety. So in this particular application, if you have a really safety critical device, if one of those 2 solenoids fails, then the system will shut off. So they're looking for the ability of, for example, if one of the valves stays open and you want that valve to shut, a 1 out of 2 system will be able to give you that shutting down system immediately. A 2 out of 2 increases the availability. So again, when we talked about nuisance trips, They want to be able to say that if one of the valves fails, or if one of the valves receives a nuisance trip, they don't want the whole system to shut down. So we want a 2 out of 2 system. So in that particular system, what we're able to do then is both of the valves have to shut down for the whole system to shut down. And then a 2 out of 3 is the best of both worlds. So we have a more secure voting system, which increases reliability and increases the availability of the product. So how we used to do this in the past is a mixture of lots of valves. So again, what we have is a 2 out of 3 system using individual valves and equipment. And as you can see there, there's a large number of pipe work. It's very complicated. Each of those pipes can be a potential failure point. You can get leakage on all of these points, and it's quite expensive to produce that product. So with the 2 out of 3, the direct valve to valve design, we have our own incorporated manifold blocks, and internally a lot of the functions of the valves that you can see on the left hand side in terms of shuttle valves, etc. Those are incorporated inside the manifold. And again, we're able to get advanced diagnostics, so we're able to look at the pressures going through the valves. We're able to look at pressure switches on the bottom. And what we're also able to do is we're able to shut off each individual valve. So if one of the valves does actually fail, burnt out coil or not functioning correctly, we can individually isolate each of those valves, remove the solenoid, replace it with a new solenoid, and put the system back into service, again, without interrupting any of the systems. So the valve itself is built on a solid design. So it's built on the 327 design. And the 327 is a very high, safe and proven technology. The 327 has been in service for around close to 30 years now. And we have a very high safety integrity level on the device, and we're constantly updating that and moving with whatever the industry looks towards us to do. And again, we can have 1 out of 2, 2 out of 2, 2 out of 3. And looking at digitalization, what we have here is we have an example on the left-hand side of an ARCS system. And as mentioned before, we've got some rose mount transmitters on this particular example on the left-hand side. So again, they're moving from the floor to cloud by being able to transmit that data wirelessly to a control panel, or even up into the cloud, or to a desk anywhere in the world, and they're able to transmit that data of how that's functioning. On the right-hand side, I've got an example here at the top of a system where the customer is looking to replace the valve. So on the left-hand side here, you can see the valve system that this is controlling, and this was in the power plant. And by understanding his pain in terms of, again, he suffered a lot from nuisance trips, where the system was closing down and shutting off prematurely without the customer wanting it to. Then we offered the customer an ARCS system. So we replaced his current valve structure with an ARCS. And again, he'd seen some real benefits in this, enabled to him to not shut down the plant and see some real benefits. So again, this is, looking out to understand what the customer's pain is, and being able to offer something like an advanced redundant control system to alleviate his pain. So not forgetting what we're able to do within our infrastructure. So I've got an example here of a process dashboard. So in a lot of processes, we're looking at different ways of being able to give a customer solutions. So obviously this is an older solution in terms of, using the Grafana software, but typically we can also use the Movicom software and be able to, give a customer a graphical display of how that valve is functioning, and give him some feedbacks that is unique to his particular system. So whatever is important to that particular customer, we're able to give them a solution, either be using Grafana, being using Movicom, or some of the other systems that we have in place. But it's just to give you an overview, again, with that ARCS, how that can be converted into a digital solution, and what we're able to offer the customers. So moving on to the next now with the Aventix products. Again, we've probably seen this a few times with the AF2, the airflow sensor, and we all know about the features and benefits of what that can give to you, but transferring that into solutions, again, it's very important to the customer to be able to monitor how much air is using. And within the process industry, we've seen that typically when a customer puts a product together, they may test a complete valve system. And if we're able to give them advanced diagnostics or advanced features, typically a customer will never know how much air is being consumed by his device. And enable for us to show him how much air is being consumed, we could connect it to an AF2, and then he'd be able to constantly monitor that device and give him feedback, and he can act upon that feedback. What we also have is the PL2, the PEL5, sorry, which again is just a sensor. And by analysing a sensor over time, again, we can do some IoT data and some statistical feedback, and we can analyse that and be able to give a customer solutions onto whether his product is working correctly. So what I have here is some examples of where I've connected this to, again, devices within the process industry, and we're able to again analyse with a device such as an actuated package what that means and how we can use an AF2 to give advanced feedback. And we've sold this to our distribution network, and again the distributors have seen the benefit in the SPA 2.0 case. So at site he can then analyse when he's tested the product in-house, how it's performing correctly. He can note down how much air is being consumed, how much air is being, how long it takes to open, how long it takes to close. And then on site he can use that data again to analyse whether there's any deviation in the product from when he first set it up to when it's been in service, and that'll give him some insight data into whether the valve is potentially failing or close to failing, and he can perform some maintenance. So yeah, you know, we've seen some benefits within the process industry of where this can be used. So again, looking at some of the solutions that we have in place, so pack machine addition, so we're able to analyze the PLCs and connect to the PLCs. And then using Movicom, we're able again to give some graphical data. And again, on a particular customer's plant, we can devise this data to be relevant to how his plant's performing. And again, he'll be able to quickly analyze his system without using advanced systems like an AMS or something that Emerson already supply. We can look at different discrete automation solutions. It may be that the plant that he's using doesn't have the ability to input these advanced systems. It may be that he's looking at skids, or he may be looking at different areas of the plants where, you know, his process may be under a Delta V system, but his wastewater plant may be under a different system, and how does he communicate those together? But by using the Movicom software, we're able to give the customer direct solutions to be able to analyze his plant and work efficiently. So again, moving forward, one of the areas where we're looking at is obviously within the process industry, a lot of products can be in a hazardous zone. So we're working together with our product managers to see whether we can actually put this device inside an explosion-proof enclosure, and then be able to offer the customer a zone 2 solution maybe to enable him to be able to use this device. So it's just an idea of where we're going forward on some of the advancements, especially in the process industry. So moving forward, so it's typically just looking at what we have in our portfolio today and understanding what the customers need to help them achieve a return on their investment and positive results. So target industries within the process industry are oil and gas, chemical, energy, petrochemical, water, wastewater. And then some of the people that we want to target are production and maintenance managers, safety managers, energy managers. And for each of these different people, they have a different need, if you like. So obviously a production manager is looking at making it more efficient. He wants to know, okay, what can you make my system give me more money in effect? What can improve the efficiency of my system? So again, by having this analytical data, he's able to maximize his plant uptime. He's able to reduce his unplanned maintenance or his unplanned downtime, and be able to make his system more efficient. The safety manager, he's looking at a different aspect. He's looking at compliance with safety regulations, reducing hazardous exposure, and what can he do to improve his plant. So again, things like an ARCS is able to improve the safety of his devices, and be able to offer the customer, advancements on what he's currently have installed. The energy manager, what he's more important is how does he reduce the greenhouse gases? How does he increase, his energy consumption reports? How does he perform assessments of energy? And again, we've done this locally within Skelmersdale by just looking at the energy consumption of our compressor. If we're able to monitor that, then perhaps we're able to reduce the amount of time that compressor's on, because of the leaks that may be performed that we're not aware of. And in doing that, we're looking at reducing, our carbon footprint by 5 tons per year, just on a simple task. But obviously, the customer hasn't got that infrastructure in place, so he's not able to do that today. But just by adding a simple AF2 and a compressed air management system, that's an easy way of being able to give the customer a very positive and easy result on how to reduce his energy and reduce his greenhouse gases and his carbon emissions. So looking at the process industry team, so we've got process specialists. I mean, technically, these are guys that may not have the role as process specialists, but these are guys that have the knowledge of the industry, where that these solutions may be a benefit. So, in the different areas, we've got the process experts or the process knowledge base of the people in the different areas. So whatever area you're located, reach out to your process knowledge. And of course, we have the business development team, which some of these are on the call today. So Stefan Vanucci is the process group business development manager, and he has a team underneath him that work towards, being able to support any of our customers in this field. So that was a very quick sort of overview of what we have to offer in the process industry, and I'll just pass it over to Anya to give you some additional support available to you.
Yeah, thank you, Mike. Hi everyone. Just to finalize the presentation, we put there, some slides which with direct links to some tools and associated documents such as presentation, flyers or video, and sometimes you're gonna find also some, let's say more detailed training according to the different products that we were covered during this training. Yeah.
Thank you. So again, it was just all we wanted to do really was just give you an overview of what we have within our product portfolio that relates to the process industry. Obviously, it's always very quick to go over this presentation, but we're always here on hand to support any of you. If any of you have any questions or want me to go over any points that we've gone through in the presentation, I'm happy to do that now, or obviously reach out to me after the call. But really, we can see some benefits in the products that we have available. It's just highlighting what's there and what relates to the process industry and how that can help you in your DX journey.
So, Mike, we have some questions on the chat.
Okay.
So the first one from Stefan Vanucci, who is asking if you're going to share later the reference and installed base for this solenoid equipped GoSwitch.
Okay. Yeah. No problem. I can give you those references in install bases. No problem.
Okay. So this. The second question is that from Willie, if we have the MTTF for GoSwitch or SIL.
Yeah, so the mean time before failure and MFT data, we have SIL certification for Go switches, so we're able to give that data across. So we have that data available, and again with all the ASCO products, we use Exceeder for our SIL calculations. A couple of the different SIL providers manage the results in different ways. So Exceeder uses mean time before failure. TUV uses different method, but again, we're able to do this. And if you have any specific requirements for SIL, just to obviously if it's SIL 2 or below, then we're able to calculate or create a SIL certificate in-house. So if you have any specific SIL requirements, just to put it out there, then we're able to do that as well. So again, sometimes you may have a specific application which requires a different SIL value to what we propose on the certificate. And we were able to check within our engineering team what we can provide. And in a few cases, we've been able to provide SIL certs that are outside the standard SIL 3, but specific to a customer's requirements. So that we're able to do.
Thank you, Mike. Yeah, as we have some minutes, if you have some other questions, then feel free to unmute yourself.
So Stefano has asked a question. So the AF2 X-Proof version is something that we're investigating at the moment. So again, if you feel that you have a requirement for this, then obviously we're looking to advance our product portfolio. But we'd be happy to understand if there's an immediate need for that, and that will help us again moving the MPD to the next stage. But there is I believe there is an IQ base that we're looking to implement and look at that going forward.
Good afternoon, Stefano speaking. So thank you for the great presentation, Mike. And you have put a good overview what process product we could get from the DX solutions. Regarding the IF2, I would just comment that, guys, if you have some requests, please refer to what the competition is installing, because we have, with Stefano in Italy, we are facing a discrepancy between what the product is and what the ATEX certification is requiring. So make sure that the solution that is in place is really aligned with the ATEX, which is today what I've seen in Italy. I'm doubting so from the competition. So that's why Mike has shown an IF2 into a cabinet, because I don't get any product from similar to IF2 from competition being able to be installed in explosion-proof area without any protection. So that's why. So please check again when we have this. So regarding the application, yes, because I've already been in that process to propose energy monitoring to process activities like chemical, petrochemical. So that's why I was asking some references, because it would be good to also give some guidelines to people where the air monitoring, or because that's the first level we are talking about here with IF2, is more critical than the rest. And for isolated valve and so on, as you said, it's more critical on the reliability of the operation of the valve more than the air leakage, except for the piloting. But for instance, for petrochemical tank or refining, where they have a lot of concentration of valve, then maybe the air consumption could be more critical than people are thinking. Because in most cases, people are saying oxygen, nitrogen, or all these typical gases are more critical to just monitor the air and to monitor it. So that's why I was asking some references to give also some guidelines to set people to know in which are the typical applications and subsegments where the air monitoring, and beside that, going further to gases monitoring is really critical for the manufacturing.
Thank you, Stefan. Okay, so I think that's answered the questions in the chat. I really appreciate you all being able to attend the training today. And as mentioned, we'll put the recording out to those who weren't able to make it. And I'll also make the presentation available to you guys for you to be able to send to your customers or take extracts to give to your customers. Thank you very much indeed for your time. Thank you.
Thank you, Mike, for this training.
Problem.
Thank you very much, Mike. Cheers. Bye.
Thanks, Mike.
Thank you,
Thank
mate.
you all.
Thanks, mate.
Thank you very much.
Bye bye.
Thank you. Bye.
Thank you all. Bye.
Thank you. Bye bye.